Nowadays, we hear the terms artificial intelligence and machine learning all the time. We hear it in the context of driverless cars, we hear it in the context of modern manufacturing, games, and even modern surgery. Now, what is artificial intelligence and what is data science? Before we get into the details of each of these, let's look at the bigger picture. Both these topics stem out of a broader field called data science. Now, data science is an interdisciplinary field which uses scientific methods, processes, and algorithms and applies them to large amounts of data to provide real-world solutions. Data science sits at the intersection of statistics, mathematics, computer science, and engineering. A lot of solutions today are evolving out of these techniques which make us more efficient and also make our lives much easier. We will take a look at each of these in the rest of the video to come.
To understand machine learning, we first need to understand how traditional computer systems work. Traditional computer systems are programmed where there is a program which for each expected input there is an expected output. The programmer has to program for each condition when the input is for certain inputs what the expected output is, which works very well for situations where there is a structured process. Say for example, in an assembly line, when the package reaches a certain location, it needs to be pushed out. So that's very expected. So the programmer can expect those things and write conditions for these things to happen. In certain situations like the ones where the inputs are always not the same, in those situations have traditionally used humans. That's the place where humans have traditionally been used. For example, when we go to the bank and we give a check, on that check the people have written the name the check is addressed to and also the amount in different writings. My writing will be different from your writing, will be different from someone else's writing. And it is humanly not possible for a programmer to write exact specifications of the writing of all the people in the world. In that case, the human is the only way which can detect whether the check is good or can be cashed or not. But that's changing with machine learning. Machine learning makes the machines work like how children work. Say for example, if we have a child that's born in a family, nobody ever teaches the child how to walk. Nobody that ever really teaches the child the grammar and the structure of the language and say, hey, this is how you talk. The child observes the surroundings around him or her. He or she sees how other people talk, and that's how the child picks up how to have a conversation and how to communicate their ideas and how to get what they want using speech. Same way, the child is not taught how to walk. They get up and they see, okay, other people are standing up and walking. They try to do the same thing themselves. In that process, they get up, they walk, they fall down, and then they actually learn from that falling down also. They are not only learning from their surroundings, they're also learning from their own mistakes. The machine learning algorithms work the same way. They learn from the data that they're provided, and they also learn from their own mistakes. So that's how they keep getting better. So the machine learning algorithm could be used in the check scenario I mentioned. The check has all different kinds of writing on it. Over time, the algorithm can be trained to identify different writings of different people. But then if it comes across a writing which it has never seen before, just like the humans, it will be able to identify that writing as well. So that's the beauty of machine learning.
In this demo, we can see how TensorFlow can be used to create an application that can detect and recognize objects on a video stream from our phone. Here, we use pre-trained models to detect objects and label them on the video feed. We can improve the accuracy of this application by supplementing the pre-trained model with our own data set.
Machine learning can be used in many other situations as well. Say for example, autonomous driving. The machines can learn how humans drive, and over time they can figure out all the different nuances and all the different situations and what to do in those situations. Machine learning is also used in medical industry to identify radiology results and so forth. So if there's an image and some human had to detect whether there's a fracture or not, or whether there is a particular condition or not, the machines can be trained using a lot of data from the past. They can be trained, and using their knowledge from the past, using their experience from the past, they can make predictions about the future, right? So now machines can only do the task that they are trained for. Say for example, if you take the example of a check, this machine learning algorithm has been trained to identify the text and the amount and the signature on the check. If the same algorithm is provided a letter that's sent to the bank, it obviously cannot read it. So it doesn't know what to do with it. So machines are not broadly they don't have a broad intelligence. They have very limited intelligence to do the task they're assigned to do. That's why many people call it artificial intelligence, but of a very limited scope, right? Some people also call it weak intelligence. Then let's take a human example. Humans have something similar to machine learning. They have the ability to learn from our surroundings, but let's say if a child or a youth knows how to play basketball, he or she has been trained only about how to play the basketball. But they someday go to the field and they realize everybody's playing a football and they have never played football before. They can still join the game and start playing, but obviously they are not going to be very good at it in the beginning because they have never learned it. But over time, by themselves, they can learn it, right? So the same way that it's expected, the machine learning algorithms will get so smart, they can not only do the task that they are trained for, they can do other tasks which they are not trained for. They can use the existing data that's available on the web to train themselves for other things. Say there's information on videos, there's a Wikipedia, and there's so much other sources of information. So the machines can now be expected to do things that they were not trained for. And that's where many thought leaders are concerned about. That's where we get into the realm of strong AI that can do tasks that we never trained them for. So in those situations, we got to be careful to make sure the AI is trained for ethicality, because humans are beings which don't always do tasks based on what is the most efficient, what's the most fastest. They also consider ethics in the mix. So if ethics is not considered in the mix, then we are going into a realm which can be very dangerous, and we may be in a situation where these machines are behaving in a way which is not going to be ethical, and it's going to be a biggest calamity for human beings. So we got to be careful to make sure that when these machine learning algorithms are becoming smart, they're becoming to a level where artificial intelligence is going to be very, very superior than it is today. We got to make sure that machine learning includes the aspect of ethicality in it. That's why many thought leaders got together and they created an organization called OpenAI. The OpenAI's role is to promote safe machine learning and safe AI. We hope all of us enjoy the world of machine learning, as it's considered to be the biggest invention of our time. It's considered as big as the internet. We will have a lot of rewards that we're going to get out of it, and at the same time we hope it's going to be a safe future.